Hey guys, today we will learn about transient recovery voltage. This is also, the LC vibration, because of the LC vibration, that or swing we say, right? It's happened. So let's see what is that. Hmm. First of all, okay, we first of all need to learn about the circuit. Okay. So this is our general circuit, right? Here's a source, voltage source, AC source, right? And as I said, here L, and they should be R, just resistance in the circuit, right? And C here. And then this is a breaker, CB, we say. I will say this is A point, this is B point, okay? And, in general circuit, I said that the circuit is always RLC, right? But in the circuit, because of the its cable also has capacitance, right? So that's why there's between cable and the ground there's gap air, right? So we say this is ground capacitance. We will later learn about this deeply, so don't worry about it, okay? So what I mean is if the it's a general in the general circuit, if there's load here, right? And CB is generally it's normally closed, which means connected, right? When CB works, which means make it the circuit open, right? So in general, situation when it's the load, it's connected. This C capacitance, ground capacitance, it's no has meaning because most of here's I total I will say, okay, IL, but this is I1, this is I2, right? So if we remember the Kirchhoff's law, right? The this point from here, I1 plus I2 equal IL, right? But 99% is I1 or 99%, yeah, almost, like 90%. So which means in this circuit, actually there is a C, but now, we think this is not now just RL load circuit, RL circuit, we just think in general situation. But the thing is, if the fault current, short is happened, so what does that mean? So at the time, the breakers it's working, right? And then it make a circuit open. So at that time, RLC, RLC. So actually, LC vibration happened, right? As I said, the LC because of a different, property, they give them like energy. So that's why they swing, right? This way. So when it's open the break circuit, like if the short, happened, right? For example, the fault current, right? So at that time, this now, IL is uh, in the RLC circuit. That's why, uh, now if the fault current happened, we now consider the RLC, the vibration, right? Yeah, and let's look at more. So look at that. So this color is fault current, and this green is system voltage, right, in the circuit. For example, here, I'm not sure lead is okay. Okay, for example, if this red line is circuit breaker, CB, when the CB is opened, if the CB is working, what I mean is it make a circuit open, right? But that time it needed like LC's vibration happened, right? But look at that, for example, as you guys know, if the current is flowing, whatever current is, it needed stop like following the current. I mean, is it disappeared. The current is the 0 point, current 0 point here. You can see here. It's has to be stopped here, right? So it's, as you guys, we already learned about L or C properly, right? So voltage or current is cannot be changed sharp, sudden of change. It needed connected, right? So that's why, we accumulated these knowledges, previous lecture. If we understand this, now we can understand. So if the CB is open, what happened? It's this arcs happened, right? Okay, I will change this. Arcs happened here. And then the fault current is, it stopped it at this point, at zero current point, zero, current point. It stopped. But that time, look at that. Here's a V, right? Here's a, so that time it wanna, it, it changed to be LC, right? LC circuit, as you guys remember, right? So it happened, this swing. But look at this. So this, at this point, it wanna be to here, like but so that's why we say this is a transient recovery voltage is happened when the circuit breaker opens and zero current at the at the zero current 0 point, when the current is stopped and recovery, transient recovery voltage is happened like this. Okay, because of the LC, it gotta be LC circuit, right? So as you, what I mean is, first of all, because of the arc's resistance and the circuit's resistance, so it cannot be like almost, two times more bigger. Like this is the voltage is wanna be reaching point, right? But because of LC vibration, it gotta be almost double, right? Almost double. But because of the arc resistor and the circuit resistor, it cannot be. And it stopped like, yeah, it swings like this. And when it, recovered, this is now, the voltage is gotta be same, like as a system voltage. You guys can see here. System voltage is, it's recovery voltage same. So look at that. What I wanna say is, I mentioned, give us a sec. As you show you guys. Okay. Yeah, it's better to. Yeah, we don't need to see here. So look at that here. I said before here, A point and then B point, right? So when it opens here, right? What I mean is, when it opens, so fault current is happened here, right? So when it circuits opened at this point, okay? So because of the L's, property, it need to be arcs happened, right? And then it stopped, the fault current is 0 point, current 0 point. And then the recovery voltage, transient recovery voltage is happened because this voltage wanna be, to a same voltage like a source voltage is voltage. It wanna be to the A point. You know what I mean? A point wanna be the source voltages. You know what I mean? So that's why it gotta be wanna be here. But because of LC, it gotta be almost double, right? And then it started recovery, transient recovery voltages happened, we say. And from this point, you guys see it gotta be same, right? We say this is a recovery voltage. Actually, this is, if we understand the L and C's property well, it's a concept, right? So yeah, that is TRV I wanted to say. So let's see more, guys. So here you guys can see, I said transient voltage, right? Recovery voltage. We also say also restricting voltage. It's the same meaning. You know what I mean? Recovery voltage, it sometimes says when it, the voltage is it's gotta be the source voltage. We say it's also just recovery voltage. But different term, as you guys can see here, transient recovery voltage and the restriking voltage is a different word, but same concept meaning, okay? We could say both of them. Don't worry about it, okay? And this is, as I showed you guys, this is a general our, power system, voltage source and L. Yeah, in the circuit there's no R, but actually there's R. Always have to be, right? And this is a capacitance ground, right? So generally, when it's connected to the load, the C is the C is circuit is we don't care about it actually because most of current is going to the load, right? But when it fault current happened, like short happened, when breakers open, it gotta be LC. That's it. And yeah, we will also learn about some of the how to the operate time, like operation, operation ordering. You know what I mean? How it mechanism of the CB. So just a little bit understand about, okay? So there's a bus bar and the circuit breaker. It's working when. So here's the CT. Maybe I explained about the previous lecture CT and PT, right? So first the CT, it's detect the fault current first, and then its relay course is working, and then it started trip current. So trip circuits, it's a they order. Oh, it couldn't work like that, and then trip course is working to CB, and then it opens the circuit breaker. You know what I mean? So what I mean is CT first it needed time to detect the fault current, right? At least one period of sine wave, and then it need to also order, relay coils process. What I mean, mechanism process. It needs some time. Relay coil is, exciting or working. We say, right? And then it also need to order the trip circuit. Trip coil is it need to working. So it needed some mechanism time, to do this. So we say, yeah, just to understand a little bit of this mechanisms order. Later, yeah, if we have a chance, we will learn about it later, okay? Don't worry about it. And the last thing is, we have a circuit breaker, but we know about the circuit breakers, breakers extinguishing material. There's vacuum, oil, SF6 gas or air, right? So there's we I will try to make this yeah, next time I will make about when I'm considering make also generator and transformer and some part more, you know what I mean? Later, I will, when I have a chance or time, I will make more about the circuit breakers, mechanism more deeply, you know what I mean? And what is the extinguishing material, how it, why we choose like this, you know what I mean? So for example, at low voltage, we generally use air, and MV class, we say we use vacuum, and high voltage, not middle voltage, what I mean is, and high voltage we use SF6 gas, like that. It's just you don't need to consider about too much about right now about circuit breakers, okay? Just remember, because of this transient recovery voltage, what is that? How it works, right? That's it, today's lecture. Yeah. Have a good night, guys.